Welcome back. So we're practicing how to check our solutions to given equations. Very important because we actually can assure ourselves that we always get the right answer for our equations, so we really want to get this down. So let's look at a few more examples. We want to check the solution x equals a minus 12 over 5, and we want to check and see if this solution is indeed the valid solution for the following equation. We have x over 2 minus 3x equals 6. Okay, so how do we go about doing this? Well, everywhere we see x, we plug in the value for x into our equation. So let's go ahead and do that. We have a minus 12 over 5, put it in parentheses because we're substituting in, and that's divided by 2, minus 3 times x, which is a minus 12 over 5, equals 6. Okay, and if this side of the equation equals this side, then that means our solution is indeed a valid solution for our equations. So we simply just work this out. All right. We can actually rewrite this as a rational number, a 2 over 1, and we know when we're dividing a rational number by a rational number, we don't ask why, but we flip the second and multiply. So we have a minus 12 over 5, and we flip 2 over 1, so instead of dividing by 2 over 1, we multiply by 1 over 2. Okay, let's go ahead and write that in parentheses just so we won't get confused here. Minus 3 times a minus 12 over 5, minus and a minus is a positive. 3 times 12 is 36, divided by 5, equals 6. Okay, we just canceled out our minus signs, giving us a positive, and multiplied 3 times 12 over 5. Okay, so moving on, minus times a positive gives us a minus. 12 times 1 is 12. 5 times 2 is 10. Plus 36 over 5. And this should all equal 6. Alrighty. We can actually simplify this as we go along. We have a minus 12 over 10 simplifies to 6 over 5. We pulled out a common factor of 2, and this will actually work out nicely because we now already have a common denominator for when we add in the next step. We add our rational numbers. We have 36 over 5, and we have a negative 6 over 5. Positive wins out, so we have 30 over 5 equals 6. 30 over 5 is 6, which means our answer checks out, which means that our solution minus 12 over 5 is indeed the valid solution for this equation. Okay, let's do a few more of these. Let's say we want to find out if x equals minus 6 is the valid solution for 2x plus 5 equals minus 7. Okay, so what we want to do is we want to plug in minus 6 everywhere we see x in our equation, which we actually only have it in one place. 2 times x, which is minus 6, plus 5 equals a minus 7. Positive 2 times a negative 6 is a negative 12, plus 5 equals minus 7. And minus 12 plus 5 is a minus 7, and we have minus 7 on the other side, which means our answer checks out, and this is the valid solution for our given equation. Let's do a few more of these. We have y equals 7 over 2. We have the solution y equals 7 over 2, and we want to find out, we want to check our answer and see if it's the valid solution for the equation 1/2 y, 1/2 times y, plus 3/4 equals 5 over 2. Okay, so let's go ahead and plug in 7 over 2 everywhere we see y. Once again, it's only in one place. 1/2 times y is 7 over 2, plus 3 over 4 equals 5 over 2. Multiplying rational numbers, we multiply numerator times numerator, which is 7. Denominator times denominator is 4, plus 3 over 4. And this should equal 5 over 2. If it does, then that means our solution is correct. If it doesn't, then we have an invalid solution. But let's see. These already have a common denominator, so we can add across the top. 7 plus 3 is 10 over 4. And we have 5 halves on the other side. And 10 over 4, if we pull out a factor of 2 out of top and bottom, we get a 5 halves. And 5 halves does equal 5 halves, which means 7 halves is a valid solution for the equation. Okay, let's see. Let's say we want to check the solution z equals 2. And we want to check it for the equation 3z minus 8 equals a negative 2. Okay. So let's go ahead and plug in our value in for our variable. 3 times 2 minus 8 should equal a negative 2. 3 times 2 is 6. Still have our minus 8 and our minus 2 on the other side. 6 minus 8, or 6 plus a negative 8, is a negative 2. And we have our negative 2 on the other side, and negative 2 equals a negative 2, which means z equals 2 is our valid solution for the given equation. Okay, let's get one more in your notes. Let's say we have a equals a minus 8 over 7. And we want to check that this is the valid solution for the following equation. We have 4 times 2 minus 4 times a, which a is a minus 8 over 7, equals 30 minus 2 times a, which is a minus 8 over 7, plus 3. Okay, that's kind of a lengthy one, but let's just take it one step at a time. Let's start by plugging in minus 8 over 7. We already did that. I actually skipped a step here. It's supposed to be a's. Just bear with me. We just skipped a step. All right, so let's work from the inside out in the parentheses. We have 4 times 2 minus, minus and a minus. We're multiplying two negatives, so that gives us a positive. 4 times 8 is 32 over 7 equals, we have 30 minus 2 times minus 7 and a plus 3. 3 equals, we want to write that with a denominator of 7, so that's the same as 21 over 7. So we have a minus 8 over 7 and a positive 21 over 7, which is a positive 13 over 7. Okay. We have 4 on the other side times, we want to rewrite 2 with a denominator of 7, so we can add these two fractions. This will be 14 over 7. 14 over 7 is the same thing as 2. So 14 over 7 plus 32 over 7 is a 46 over 7. And we still have, on the other side, 30 minus, let's go ahead and multiply these two. 2 times 13 is 26 over 7. Running out of room here. 4 times 46 is, well, that's 92, so that's 184 over 7. That equals 30 over minus 26. 30 over, let's make sure we didn't make any mistakes here. 34, 32 over 7, 13 over 7. Okay, we're good to go. Okay, 30 minus 26 over 7, we want to rewrite 30 with a denominator of 7. So 30 is the same as 210 over 7. So we have 210 over 7 minus 26 over 7. So still have 184 over 7 on the other side. 210 minus 26 is 184 over 7. This checks out, which means minus 8 over 7 is indeed the valid solution for the given equation. I didn't write the original equation, but I went ahead and substituted in for a, but this is supposed to be an a, this is supposed to be an a. But nevertheless, I hope we pounded home the importance of checking our solutions, because if we do so, we can get our equation right every single time. I'll see you soon.